Hello everyone. This is the next part of tutorial videos, and in the last video we've added such fox that can run away from a player after aggressively looking at it. And in the last video you could mention how easily it was added, so that we didn't need to add a lot of new functions. That's because of inheritance of animals and because we have an animation blueprint that can be inherited. Today we gonna add some attacking logic. So to do that we have to change our perception handler component. Now it only how it works. It changes the state of an animal to an interrupted state, and after some time it calls on interrupted function that changes a state to run away behavior. But um, it works for though only. But for fox, it should attack a character. So what do we need to do? We need to write some logic for attacking. Now we have a variable called runaway actors, and we should have a variable like attack actors. But also, for example, for my fox, I want it to attack an actor, but then run away if, for example, it lost some health or or yes, only if it lost some health. So just a set of attack actors is not enough. We have to configure when it gonna attack and when not. So I'm gonna create some configuration file. So let's open our components. Here we have BP perception handler, and let's create a new structure call it some s attack behavior config. And what we're gonna have here, we're gonna have a set of actors. So actors to attack, and it is gonna be an actor class reference, and it is gonna be a set. So here we will have a set of vectors that will be attacked by our animal. But we also need some conditions. So let's add, for example, some condition. Let's create a new structure and call it as attack condition. Open it up, and what we will have here? We will have some condition, and it is gonna be, we don't have an operator, I think, between two incoming fields. Okay, what is an operator field? Let me check it. Nothing. So we will do it simply. We're gonna use a string, and it can be less, equal, be more, less than equal, not equal, and greater than equal. So we'll have base mathematical operators here. Or why I'm doing this with string, let's add an enumeration and call it e condition operator. And let's add some operators. First one is going to be this one, then this, this, this one, and this one. So condition is going to be this type of enumeration, e condition operator. And next we have to have some value. I'm not sure that we can create some generic structures here in blueprints and in C++. I don't remember, to be honest. So what do we need? We need some value, but we don't know what type of a value. It may be Boolean, so we have to check maybe something like com compare values. No, something that I will just Google to find how it can be done. Okay, I didn't find anything, so let's create a new enumeration. We'll do it like this and call it e condition value type, and let's add something here. Let's add int float, oops, float string vector and boolean. That's it. And now let's go back into attack condition, and we will have some value that is going to be a string that will be converted then. And let's add a new field called value type and call it e value e condition value type. So this is our condition. This is how it's gonna look like. Now let's close it, and attack behavior config will have its conditions. So first let's add health condition here on attack behavior. And it is gonna be as condition. Oh, as attack condition. And it's not gonna be a set, it's gonna be a single field. Next, we may add something like position condition or maybe distance condition. Yeah, I think distance condition is fine. And let's open it up, and default value for health condition is gonna be health is float and distance is also a float. Also for condition, let's add one more field like is enabled of type boolean, and by default it is enabled. But for example, if we don't want a health condition for attacking for some particular actor, then health condition is gonna be disabled. But now let's enable them here like this. So that's all. Now what do we need to have in our perception handler? We need to have this config. So let's call it attack config. And here it's gonna be a type of s attack behavior config. Let's make it public. And by default, we have every condition disabled, and attack directors, we don't have them. So now let's open our animals. Let's open our fox, and let's change these conditions for our fox only. Let's find it at first. Um, oh, it's in perception handler. Attack config. So actors to attack will have BP main. Oh, we what? Actors to attack. Did I create it not a set of class references? As tag behavior config. Attack actor action utility type. What? Okay, it should be an actor, not an actor action utility. I just misclicked. So now we can compile it, and now we can add some clear, delete, Why you can select an actor to attack? But um, it's very strange. Actor class reference editable. Here I can select it, but on BP Fox I have nothing. Okay, maybe let's close BP Fox and open it up again. So attack config, actors to attack, none. Um, well, let's BP main character. Let's open it up, show in folder, and try to do it like uh, okay, I have to compile perception handler so that it will fix it. Okay, now let's select BP main character here, and now it will be the only actors that we're gonna attack. Runaway actors is gonna be clear for now. So health condition, we're gonna attack while our health is greater, for example, than some value. I don't know what value. Let it be 30 or 50. And it is enabled. And distance condition, while distance is less than 500 and enabled. By the way, now we don't have any health or something else stats on our animals, but we will add them later. Now let's add a logic for our perception handler. So let's open uninterrupted, and here we are setting a behavior to run away. But we should also check if we should attack and not run away. So let's create a new function and call should attack, and let's add a category and call it attacking, because we'll have, I think, a lot of functions here. So here we're gonna get an attack config, break it, oops, break it, and first we're gonna check if actors, we're gonna check if current interruption actor class exists in this set of actors to attack. So let's get our behavior config, also break it, and here we have an instigator. Now we need to get class of this instigator and check if actors to attack contains this item. So let's move it down here. Okay, and let's promote it to variable. Promote to variable, and oh, we should promote it to local variable. Promote to local variable, and call it um, set condition passed. And if it contains, it's gonna be true. Next, we're gonna check health condition. So let's add a new function and call check uh, health condition passed. And what we're gonna do here, we're gonna get the config, break it, and we have to check in this function whether health condition is passed. So let's break as condition, and let's make a branch. If it is enabled, then we're gonna do something. If it is not enabled, we're gonna return true. We're gonna return true, and let's call it passed. So if it is not enabled, then the condition is passed. Next, what we're gonna do here, we don't have health right now. So we're gonna, for example, let's make some float. Um, Equal, no, we have to switch on a condition. So we're gonna get a condition. We have different signs, by the way. We're gonna switch on condition. So now let's create a function called get health. Move it to attacking, and it's gonna return us some float value. The output is gonna be health float. So in health condition passed, we're gonna call this function get health. Also let's make it pure function. So now, if we're checking if health is less than this value type, so we're gonna get health checking less than value than just our value. Let's make float or string to float and make this condition. And if it is true, then we're gonna return this node. Next, for this sign, we're gonna check like this and also return node. Next, equation sign to this float and also return result. And the same, so let's copy health, not equal, oh, to this. This goes here and this goes here. Next, uh, less than less equal sign. It goes here. It goes here. Connected. And the last one oh, is greater equal. It goes here. Connect everything. Okay. So that's how this function looks like. Health condition passed. So let's back to should attack and call health condition passed function and promote it to local variable health condition passed. Next, we have to check distance condition. Also, let's hide in connected pins. So we're gonna do the same, but for a distance. So let's duplicate health condition passed and name this function distance condition passed. Okay, it would be done much easier in C in using some generic functions, but I don't know if it's possible to create them here. So everything stays the same here. We should connect distance condition here, and we should create a function called get distance. move it to attacking. And what we're gonna do here, we're gonna get behavior, oh, get behavior config, break it, and we're gonna get an animal, get actor location, and get actor location for instigator, and find the distance, and return it, add return node, connect it, like this. Also, let's make it pure function. And now let's go back to distance condition passed. So here we are changing get health to get distance, and here also get distance. Also, we don't need this value type, by the way, because we can cast it here. Didn't thought about it, didn't think about it. So now let's go back to should attack and check if distance condition passed, and promote it to local variable. We'll call it distance condition passed. Also, let's do it in a sequence, because later or in future we may have a lot of conditions and they will go in a long line. So when this long line, when every condition is checked, we're gonna return a result. A result is gonna be whether we should attack or not. And it is gonna be this boolean and this boolean and this boolean. So if every condition passed, then we're returning this value, calling it yes. So we have should attack function. That will work correctly now, but for Fox it will always return true because we don't have any health. So let's for a Fox open a config and health config, let's disable it for now. Now back to uninterrupted. Here we are running behavior run away. So let's call should attack and add a branch. And if we should attack, we're gonna set another behavior. We're gonna call set behavior, but it's gonna be attack. And when we're gonna change it to an idle or something else, we're gonna have a timer that will check if whether we should attack, whether we should continue to attack. So let's add a new function and call it on attack loop. Move it into attacking group. And on interrupted function, let's set timer by function name. And its name is gonna be on attack loop. How often we gonna check this? I think that every second, maybe too fast. Every 2 seconds, we're gonna check whether we should attack or not. And let's promote it to variable and call it attack timer and move it into timer category. Save, compile. Now what we're gonna do on attack loop? We're gonna check whether we should attack first. If yes, then we're doing nothing. But if no, we gonna run away. We gonna um, call this on interrupted function. So let's just call on interrupted. It will check this condition once more, but in this case it will return false and call run away. So that's it. That's main logic for this, but our behavior tree doesn't support such behavior. So we have to add this behavior into our behavior tree. Now we have an idle when he's roaming, an interruption when he's searching who had seen him and run away from a player, but we don't have an attacking. And in the next video, we're gonna add this behavior. Thanks for watching.